Just nu var ni...
Men jag tror att det är på lektionen.
Tändala ljuset. Alltså den där roboten.
All right, mute yourself if you're going to have side conversation. We want to do, what is this problem? Chapter 7, problem 73. And I want to bring the screenshot in. Here's the problem. We can make it bigger. Can you all see this well enough?
We can't even see it.
Because I'm not sharing my screen, that's why. I thought I would do that. Good thing I asked, so good thing you told me. You can see it now.
Yeah.
And you can read it.
Yep.
Beautiful. All right. You had asked for the assigned problem for D, E, and F, or whatever it was. It's the same as these two. So suppose that the duration of a particular criminal trial is known to have a mean of 21 days and a standard deviation of 7 days. We randomly sample 9 trials. So in words, what is the sum of X? Well, we're talking about here, if we look at A, we're talking about the length of all trials added together, right?
Yep.
Let's make this bigger so we can actually see what we're typing. Okay, so it's the sum of all trials added together. What is the mean and standard deviation? Let's say I don't remember. I know that I'm pretty sure that it's going to be 9 trials, right? 9. Well, let's say mean is going to be equal to 9 times the mean of each individual trial, which was what? 21 days?
Yep.
What's the standard deviation?
7.
Frankly, I don't remember. Do you remember?
7.
Chapter 7, number 73. Okay. What do you do if you don't remember? Well, I got the textbook open here. The central limit theorem for sums. That sounds like a good idea. If mu x is the mean of x and standard deviation x is the standard deviation of x, the sum of x has n times that. We got that right. And the square root of n times the standard deviation. Because now I'm not taking the average of them. I'm just adding them up without dividing by the square root of n. If you think about it. So it will be at the square root of n times the standard deviation. Okay. So it's equal to, and this should be pretty easy, equal to the square root. And how many trials did we have? 9. That's a nice square root, should be 3 times, and then where is it? 7 days, because remember they wrote it in words here for some reason. So it's also going to be, that will be 21. So sum of x will have what? This kind of distribution. It will be distributed normal 189, comma 21. Well, once I know that, I can answer the C and D questions. Find the probability that the total length of the 9 trials is at least 225. So C is asking for what? Probability that, let's call it sum X is at least, right? So that means greater than or equal to, doesn't matter, it's the same, would be the same thing, 225. Well, normal probabilities, all I can do is the less than probabilities, right? If I was to draw a picture, I don't know, where's the picture? Doesn't matter. This is a right tail. CDFs only gives us the left tail. So we have norm dot dist. That's our normal. If we're trying to find probabilities, we use that. And what's the X? Well, it's 225. And the mean is what? 189. Standard deviation is 21. And we're doing cumulative, so it's going to be 1 or true. Now, that gives me the left tail, but I want the right tail, so I have to do 1 minus that. So I get a 4% probability that that's true. 3 or 4 decimal places is enough.
Wait, can you do that one more time?
Sure. Does that seem foreign to you?
No, kind of.
Okay. The other thing is you can use the, let me pull it up, the normal distribution calculator that we had. Announcement. Normal distribution calculator optional homework. Where did I put those? I'll just open it up from my own file. You have access to the files that I sent out before, right? So calculators. Let's open my continuous calculator up. We're using a normal distribution. What's the mean? 189. What's the standard deviation? 21.
Oh.
What's the number I want what's the number I want? The only number I really care about is this, what, 250, 225? It gives me the left tail and the right tail. The right tail is what we're looking for. Same number we got. Okay.
So if it's less than, then it's left tail?
That's, this is like a month ago, you should have known the days of the week if this was a Spanish class. This would be like the days of the week, yes.
Okay.
You should feel slightly awkward for not knowing that already. That's an indication that maybe you didn't read the book very much in between classes or try very many problems. And it's not just directed to you because you're the only one honest enough to ask the question, right? So if you aren't getting it, that means other people aren't getting it, which partially, let's say it's 50% my fault for maybe not explaining it over and over and over again, and 50% the student's faults for not like cracking the book ever in between classes. If you don't get it, and I explain it several times. I mean, I can make a picture of this. Let's see. I don't want to bring up that stupid drawing mechanism. It always looks ugly. But can you draw something that has a left tail, right tail, and in between? So you have two numbers. Let's say I put 220 in here for this, whatever it is, this number of 9 trials. And it gives me all the this gives you all the probabilities you ever want with if it's a normal distribution. Here's a mean, here's a standard deviation. I put x low and an x high. The left tails is always the CDF. If you look up here, I can't make this bigger, sorry. I can actually copy it and place it down here. Oops, that's not right. Let me copy this. And right there, I could write it. That's what it is. What's C6? That's this number. What's C2 with the dollar sign, which means if I drag it down, it's not going to change. That's 189. What's C3? 21. What's 1 mean? 1 means cumulative, 0 means PDF, CDF, PDF. CDF is always less than or equal to. It's always the left tail. I can spout that off how many times? At some point, you have to memorize it, or you have to know it. Second, I give you the right tail. How do I give you the right tail for that same number? It's pretty simple. It's 1 minus D6. What's D6? There's D6. 1 minus that. The complement gives you the right tail. If the CDF is the left tail, 1 minus it is the right tail. That's why I took 1 minus it in this problem. Same thing for the high. I could copy it down. It's going to look exactly the same, except what? Copy. Paste. What's the difference? It's all the same, except it's C7 instead of C6. I'm using this number 225 instead of this number 220. This one is going to be 1 minus D7. There it is. The in between, how do I calculate that? I subtract D7, this number, from that number, and it gives me the in between. So I have all the left tails for these two numbers. I have the right tails for these two numbers, and I have the in between. Now, if I'm trying to find a 35th percentile, I put in a probability, or CDF, which I can't remember what this problem was asking for. 90% of the trials will last at least how long? So 90 percentile means 90% of I want the 10th percentile, right? I want to find out the CDF for 10. Then the complement to that is 90%, which will tell me the number of trials that will last that length or longer. So I go back, I can do it here in D and say 10th percentile of trials. Usually when we say 10th percentile, it means if you're in the 10th percentile, that means you're a lower 10th% of the class. It means 90% of the class is doing better than you. If you're in the 90th percentile of the class, it means that only 10% of the people are doing better. So if we want a number that says 90% of will be at least this long, I want the 10th percentile. Well, that's equal to inverse, norm.inverse, sorry. What's the arguments of that? Probability, mean, standard deviation. What's the probability that we're looking for? 0.1. What is the mean? It doesn't change. It's still 189. And I could have copied it from here. What's the standard deviation? 21. Boom, hit it. So it's going to be 162. Okay, let's go back to, where is this? Textbook. See if we did this right. If you can't do the problem that was assigned to you, on one side or the other is a problem that looks pretty similar to it, isn't there? So you can see how they did it and then do it yourself. I mean, that's what examples are all about. So if I go to homework, which one were we doing? You asked about 74. We did 73. If I click on a little blue part there, it gives me the answers. the total length of time of 9 criminal trials, N, 189.21, we got that. 4.32%, we got that. 162.09, 90% of the total 9 trials of this type will last 162 days or more. We got it. So to go back to your other question, how do you do this? This one says find the probability the total weight of open boxes is less than 250 pounds. Do I have to do 1 minus? That's a left tail. It's a CDF. I just have to figure out what the mean and standard deviation is. Uniform, oh, it's uniformly distributed from 2 to 6 pounds with a mean of 4 pounds and standard deviation of 1.15. Now that's a slightly different problem. So how do you do the sum of, I don't remember how to do the sum of uniform distributions, but here's a formula thing. The sum of, we're using a sum for central limit theorem. So if it's uniform distributed, all I know is that the mean of the sums is going to be n times the number of means and still square root of, so it doesn't matter what the underlying distribution is, does it? So if I have any trouble recalling this, oh yeah, it's a central limit theorem. Everything that all sums and all the sampling, the central limit says that if I take the sample mean on a certain sample size, it tends to have a normal distribution. Doesn't matter what the population standard distribution is. For the sum, it's the same thing. The sums tend to be normally distributed with n times. So it's really the same problem. It's just that the population distribution is different. So let's go back to our problem. 74. All right. You tell me, what's the mean of the sum of these distribution? Open boxes of cereal at home, is it uniformly distributed from 2 to 6 pounds with a mean of 4 pounds and a standard deviation of 1.1547. We randomly surveyed 64 homes. What's the distribution of this sum? Bianca, this is for you.
I know, I don't know.
Then why were you asking about E and F if you hadn't done C yet? Or
Well,
hadn't done D?
wait, total weight of open cereal boxes.
Yeah. I'm adding up the boxes. I'm not taking the average weight of open cereal boxes. I'm adding them all up. I've taken the boxes from 64 homes, open cereal boxes. I added them all up. What should be the weight?
256. Wait.
It should be is uniformly distributed from 2 to 6 pounds with a mean of 4 pounds. So 4 times 64 is what?
256.
That would be the mean. That would be the mean. What's the standard deviation?
9.23.
I don't know. Square root of 4 times 1.15. Square root of, square root of 64. So it's going to be 8 times 1.1547, which is probably 9 and change, right?
Yeah.
Okay, you did that. See, you knew that. Now you use that distribution to answer the next 2 questions. What's the probability that the weights are less than 250 pounds? So I have what? I have I still want to go here. Oh, I want to use this. Okay, so now what do we have? The thing was equal to 4 times, or 64 times what? I don't know. I can't remember. 4 pounds, right? 256, correct. This is going to be equal to the square root of n which we took 64 different homes and found out the weight of their open cereal box times 1.15 something or other, 1.1547, 9.238. All right. Now we want to find out what? What's the probability that the box is less than 250 pounds? And we want to find a 35th percentile. All right, I put in 35 here. Boom, there's the answer. I put in, I can't remember that number again, 250. Let's put in 250 on that one. And do I want right or left tail? It would be right tail, so it's like 25%. And if I leave that 220, that's fine. All right?
Yeah.
Not hard to do. You see how doing a similar problem will set you up to do the right problem.
Yeah.
All right, good question. Look at all these people online. I love it. Who else has a question? Chapter problem. This normal distribution calculator is not a bad thing. I mean, you could probably do it yourself, but you could like then, I don't know. Let's say I put some numbers in here. Say I put 110 and let's say I had 25, let's say 8 as my standard deviation. I put some numbers in here. I want the low number I might be interested in is 105. The big number I might be interested in is 114. And it gives me my left tails, which is the CDF. 1 minus the CDF is the right tails. And the in between. So the probability in between 105 and 114 is 42. And if I want the 50th percentile, what will the 50th percentile be without even having to enter anything? Someone tell me. What's the 50th percentile of a normal distribution? I actually actually answered it already. It's 110. 110 is the mean. Should the 50th percentile be the mean? For the love of God, someone say yes.
Yes.
Thank you. Did you know that answer, or are you just saying yes to back me off the ledge I was standing on?
Well, I saw the mean, and then you typed it in, and I saw the 110.
Yeah.
And I figure since it's half, and you
It's
add
half.
everything and get the mean. Yeah.
That's what 50th percentile is. Yeah. You got to start having a feel for some of this stuff. Now, it's not easy. Every little thing is easy to explain, right? Putting it all together sometimes is tough. Now, the question I was asking, if I use this calculator, and if I was to copy this, can I place it here? And does it bring all the calculations with it? No, it doesn't. Too bad. That would be helpful if it did. How could I make it so it does that? Because that would make your homework much easier, wouldn't it? You just put it there and you can read the numbers off. Maybe I've got to put $sign. Oh, because I know what happened. I put those $signs in and it holds those things steady. So when I move it, it's still looking for that number that's not there. But I could do this. I could take copy. I could bring it over here and I could paste it as a picture. What do I want? Paste link. Paste picture. Now it pastes it there. It looks kind of weird, doesn't it? because it has like the see-through component to it. But what does it say? I can now say, I can tell that you use the calculator and you can pluck numbers off of this. So maybe an easy way to do it here is 189.21. If I go back to my calculator and I say 189.21, you still have to do that part right. That's the lesson. And what do I want? I want the number 225. And I can put any number there. I can just leave it as 105. It doesn't really matter. But I'll put another number in there. It's not asking for two numbers, so I'll just put one. I'm only interested in one number here. I'm only interested in this one, 0.0432, because that's the sum of x being greater than 225. The CDF gives you the left tail. The 1 minus it is the right tail, the greater than. And then I wanted the 10th percentile. Again, I have to interpret the story problem right, and I probably don't need all that decimal places, sorry. So now if I copy this, I highlight all this, copy, and paste it here as a picture. Paste special, paste as a picture. It looks a little funny because of all the lines in there, but I can get it. I can tell you pasted it as a picture, and I can see where you got your numbers. There's my 4.32, and it should be 162.9. And at least, or if you want to put the formula in here to do it, what would I do? I would do norm.inverse of, what's the probability? 0.1, comma, 189, comma, 21. Gives me that answer. I may make it 2 decimal places. I use my calculator, and then I verify that the answer I got is the right answer. Can't go wrong. This is the part that's new. You got to learn how to do this part before you can do this. Once you have your distribution, this should be old hat. That was 3 weeks ago. We were doing the days of the week. Now you're using the days of the week in complete sentences. It's a language class. You have to, what you learned, you have to learn. I just assume you know it now. Okay, another question. Bianca, that was a great question. And Bianca, if you have another one, that's fine too, if other people don't have questions.
Chapter 788.
Chapter 788. I gave ample time for other people to ask questions, did I not?
Yep.
Okay. 88. 4 friends, Janice, Barbara, Kathy, Roberta, decide to carpool together every day. Each day the driver would be chosen by randomly selecting one of 4 names. The carpool to school for 96 days. Using the normal approximation to the binomial to calculate the following probabilities. Round the standard deviation to 4 decimal places. Is this the one? Is this a problem?
No, 87 is more similar.
Oh, that's right. 88.
Kind of.
You said 88.
Yeah.
Suppose the length of research papers is uniformly distributed from 10 to 25 pages. We surveyed a class in which 55 research papers were turned into a professor. The 55 research papers are considered a random collection of papers. We are interested in the average length of research papers. In other words, X is the average length of research papers. So this is, are we looking at the sum of lengths? Or are we looking at, what are we looking at? We're interested in the average length, so it's not the sum of lengths. So if I go here, what am I using? Am I using 7.1 or 7.2?
7.2.
I said they're interested in the average length. So we're interested in X bar. I had how many? I'm not going to go back and find the problem. This is this one, 88. The survey, they have 55 research papers. N is equal to 55. What should we do? That's uniformly distributed. This is normally distributed. What's the difference between uniform? The thing still plays in. Let's do 87. Okay. It doesn't matter. The only thing with this is you have to know for the uniform distribution what the mean and standard deviation is to do this problem. Do you know what the mean and standard deviation is for uniform distribution?
Maybe. I want to say yeah.
Of course you know it. If you don't remember it, go to the formula review in the chapter where we covered it. If X has uniform distribution from A to B, the mean is the midpoint between A and B, A plus B divided by 2. The standard deviation is B minus A divided by the square root of 12. Do I remember that? No, if I did like 10 problems in a row, I'd probably remember it, but I remembered where to look. So now I'm using this fact with the formula review here. The central limit theorem for means for the first part of that question, and a central limit theorem for sums in the second part of the question. So I want to find out what the distribution of the sums. It doesn't matter what the underlying distribution is. The sum of x's is going to be normally distributed with the sample size times the mean of the individuals from the population, and the standard deviation is going to be the square root of the sample size times the standard deviation of the population individuals. That's if I'm doing sums. If I'm doing means, the mean doesn't change. The mean is still going to be the mean. The population mean and the sample mean will be the same, but the standard deviation now is the standard deviation of the population of individuals divided by the square root of n, which is the sample size. Do you have to memorize the formulas? No. Do you have to read it and understand it enough so that when you look at this, you can recall what it is? Absolutely. Does that help you?
Yeah.
So those questions, they're not even asking for probabilities in that question, were they? Let's see. Let's go back to it. What was it, 88 again?
Yeah.
See how short-term memory is the first thing to leave you. So A through D, let's see. This is a really oddly phrased question. We survey because they first ask about what is X. We're interested in the average length of research papers. And then they ask about X bar, and then they ask about the sum. So they're asking about the population. It's not clear. I'll give you that. In other words, X is the length of a research paper for a average length, or it's the length of a research paper written by a student. And X bar is uniformly distributed from 10 to 25 pages. So U, 10, 25. What's the mean? 10 plus 25 divided by 2. So 35 divided by 2 is what? 17 and a half?
Mm-hmm.
What's the standard deviation? B minus A divided by the square root of 12. Yeah, B minus A divided by the square root of 12. I have no clue what that is. I know B minus A is 15 divided by the square root of 12. It's what? 3 and change? 3.5-ish. So you can figure that out. So now X bar is the average length of research papers for 55 research papers that were turned into a professor. That's going to be normally distributed with the same mean as the parent distribution of individuals. So the same mean as in C, but the standard deviation is going to be what? The same standard deviation as in D, but divided by the square root of 12. No, I'm sorry. It's the same standard deviation there, but divided by the square root of 55, the sample size. How about the sum? That's the total length of 55 research papers. All, if I stapled them all together, how long would all those research papers be? Now I have 55 papers in one binder. How many pages would I have? So it's going to be normally distributed. The mean is going to be, take this mean of the individuals, which is 25 plus 10 divided by 2, which was 17 and a half, times 55. That's going to be the mean. It's normally distributed. What's the standard deviation? Square root of 55 times the standard deviation of this, which was B minus A divided by the square root of 12, which was 15 divided by the square root of 12. You should be able to reason that out having looked at the formulas and not have to look back and forth all the time if you do enough of these problems. How many people did I lose in that explanation? Don't be shy. There's no time to be shy. How many people did I lose? Oh, some people raise their hands. Who raised their hands? All right. Other questions? Do you want me to do a problem on either side of that or make up a problem that looks like that? See, the way this kind of class has to work at this point is I know kind of how to do these problems. If you don't know and want me to show you, someone has to say something.
Can you show us one?
Okay. That would be, thank you. Okay, so let's see let's go back. I'll share my screen again. Oops, I stopped sharing it. Let's go back here. Let's go back to my Excel file, which I'll send you at the end of this. So I just keep adding tabs down here. So this is, I'm adding a new tab and we're calling it what? Chapter 7, like number 88. I'm not going to do the homework for you. I explained how to do it, which was pretty good. Dismissal reminders go away. Where is that? Okay, so let's go over here. Let me insert a text box. So we have a problem that we can work with. Okay. Boy, I can't even think of the blah blah. Well, let's use it in this. In Professor Gabor's ops management class, paper 1, paper on define quality, the word length. For a paper on define quality is uniformly distributed with from, we'll make it simple, 350 to 1,000 words. Okay? So A. What is the mean and standard deviation of this distribution? B. Oh. Let's see, let's put it this way. Professor looked at, I don't know, 75 papers from a recent school year. What is the distribution of the means of the average or mean word count C, what is the distribution of the sum of the word counts? That's pretty much a similar problem. I changed page length to word count, and I changed the blah blah, and I separate it in such a way that it's easier to see how it looks. So I'm going to leave this up here. You all try it. I know, I'm pretty certain I can solve this, but I'm going to go get a cup of coffee and leave you to try it yourselves. And to make it even better for you, I will add some color to this just so it looks so nice. Have at it. I'll be right back. How do we do? We're probably still doing, I guess. Are people done with A? Are people done with A? Tell you what, you keep doing this. I'm going to do it, kind of do attendance while we're. Well, you can't see this if I do that. Okay, let's do A first. And I'm going to randomly ask questions of people. Alexis, what is the distribution in A?
I really don't know.
Okay. Read the first sentence of this problem out loud, please.
In Professor Gabor's op management class, the word length paper on defined quality is uniformly distributed from 350 to 1,000 words.
What distribution you think it is? The word length of the paper. Sorry. Bad grammar. What's the key terms in there that might give you the answer to what the distribution is?
Uniformly distributed.
Good. Okay, so we know it's uniformly distributed, right? So it has a uniform distribution of, you might call it this way. You might call it word length, W instead of just X. Crazy math stuff. Uniformly distributed. And we know that the uniform distribution has a lower limit and an upper limit. How do I know that? I don't know. How do I know that?
That's the formula.
It is a formula. And if you're not sure what that is, where would you find it?
In the book.
It would be in the book. So if we went to, let's see, here's where the book is, and I go to the chapter, you have to actually kind of remember, here's the uniform distribution, continuous random variables, formula review, uniform distribution, A, B. So what's my lower limit and upper limit? So in this case, what is it?
350 and 1,000.
That's pretty good. I like that. We're getting there. So it's uniformly distributed with universal equal to blah, 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 parentheses 350 to 1,000. Now, I know I don't need it for this, but I'm going to need it for the next problem. What's the mean and standard deviation? Well, the mean is what? If I go back to my formula, the mean here. Maybe I can even do this. I can do copy. You're all good at copy paste, right? There we go. I can put it right there as I do I don't have to go back and forth. So the mean is going to be B plus A over 2. So that's going to be equal to 1,000, parentheses 1,000, plus 350, can't write 350, divided by 2, 675. What's the standard deviation? Way more complicated formula, but basically it's B minus A What's B minus A? 1,000 minus 350 divided by what? Squirt of 12, SQRT 12. So I get, and I don't, it's decimal place, so let's just make it 2. How many people got that? I didn't ask for this, but I'm going to need this. I know I'm going to need it when I do these. So how do I do B?
Professor,
Yes.
what about the 2 above the B minus A? Aren't you supposed to put that in the formula?
Well, look at this. B minus A squared. What's the square root of B minus A squared? What's the square root of 4 squared? What's the square root of 2 squared? What's the square root of 3 squared? What's the square root of 10 squared? What's the square root of 137.5 squared? Someone answer that question.
It cancels each other out.
The square root of a number squared is just a number. Yes? The square root of a number squared is just a number. 4 squared is 16. The square root of 16 is 4. What's the square root of 10 squared? 10 squared is 100. The square root of 100 is 10. What's the square root of 25 squared? 25 squared is 625. The square root of 625 is 25. What's the square root of B minus A squared? B minus A. That's why I don't put the whole formula. If you can use this formula, you can do it that way. It's just more cumbersome to do. For me, I would say SQRT. Now I have to have parentheses and another parentheses, and I'm going to have 1,000 minus 350 squared. And I'm going to divide the whole thing by 12, and I'm going to put another parentheses, and I get a different answer. Why do I get a different answer? Because I probably didn't do this right. What did I do wrong? Order of operation. I probably want to put another parentheses in here somewhere. Parentheses, because it's dividing 2 by 12, and I don't want it to do that. Still gives me that. What did I do here? B minus A square root of 12. What did I do here? Oh, I subtracted it by 350, 35 instead of 350. That's my mistake. Okay, I get the same answer. Look at this formula here. And I didn't need the extra parentheses. It knew. It knew. What would I rather type? Am I lazy? Sure. Am I like you somewhat? Sure. That's that one. And I don't want to put it there. Undo. There. It's two keystrokes shorter. I'm lazy. It's the same thing. Okay? You can use the exact formula. You'll get the same answer. Sometimes I use shortcuts. All right, problem B. What is the distribution of the average word count? Well, I don't know. We're putting lots of chapters together here. Now we're doing the central limit theorem. Formula review. I'm doing this. It doesn't say it here, but if oh, that's not good. Let's do this. Okay, what is this? Copy. Why is it not doing it? Copy. Paste. Yeah, thank you. That's very unhelpful. There we go. Okay. So now I know my what? W bar. I can write it this way, or I can write it, let's write it over here. The mean of W bar, the average number of words, right? That's what I'm interested in. What's that going to be? Well, it's going to be the mean of the individuals. What's the mean of the individuals? That number doesn't change. What's the standard deviation of W bar? Which is the average. It's going to, and what probably we need the sample size here too. Let me pull this down one. And what's the sample size? N equals, how many samples did we take? 75 papers. So the mean is the same. The standard deviation is now going to be the same as this standard deviation divided by the square root of 75. Boom. So I get 21.6667. So let's take it down to 2 decimal places. So W bar, the average length of papers will have what? Will be normally distributed with 675, comma 21.67, and I need another parentheses here. Now, if I ask any questions, what's the probability of the average paper being more than 700 words? What's the probability of the average of the papers being less than 600 words? I can answer all those questions because I have a distribution that will help me get it. It's a normal distribution. Okay, so if I put the book together, of all the papers together, what's the sample size? So this is average, this is means, or mean, probably better to say that way. And this is sum of word count. This is the mean of word counts. If I want, I can do this. All right, what's my n? Is my n changed? Somebody tell me. How many papers am I looking at?
75.
That's what I think. What's the mean? What's the standard deviation of this new random variable? So let's say sum of W. Mean of sum W. Rather than saying sum of W's, I just call it sum W. I don't know. How does that work? Oh, here's when we sum it up. The sum of the whatever we're doing is going to be the sample size times the individual. And the standard deviation is going to be the square root of the sample size times the standard deviation. This is good. Why don't I copy this? I don't want to keep going back and forth, and I know I'm going to need this formula. Let me pull that up over here. Yeah, but it doesn't like that, does it? Why does it take a while to do that? No. I think it takes a while for it to be copyable. Well, let's pretend I pasted it over here. The sum is just going to be what? Equal to 75, or if I wanted to, I can make it that 75, times what? This 675. So now it's going to be 50,625 words. It's like a book. If I want to put a comma there, just so it's easier to read. Standard deviation of the sum. Of sum W is what? It's equal to the square root of the sample size, square root of the sample size, times the individual standard deviation, times that. Let's go back here, times this. Boom. So it becomes 1625. If I want to put a comma there to make it easier to read, I could do that too. Of course, if you're from Scandinavia, it won't be a comma, it'll be a period. So now what's the distribution of this? Sum W, if I sum them all the word counts up for 75 papers as opposed to taking the average, what will that distribution be? It'll be normal with a mean of 50,625 and a standard deviation. Now I got too many commas, so I got to be careful with that, but 50,625. So just so I won't use the commas just to make it easier to see the two numbers. And a standard deviation of that. Now, if I ask questions about the sum of the length of all the 75 papers or the average of 75 papers, I could use either one of these two distributions. I could go here and put those averages in, right? So let's say I wanted to ask a question about the average number of the average length of a paper. So the average length is 675. The standard deviation is 21.67. So let's see. What's the probability that I get a paper of less than 300 words? This is not accurate because I do get papers less than 300 words. What's the probability that I get a paper longer than 700 words? Or let's say 1,000 words. Well, the standard deviation is very small here. So really, the average is not going to be below 300, and the mean is not, and the average is not going to be 1,000. So really, I want to say, what's the probability that the average length is less than 600? Very small. What's the average that's greater than 700? Okay, there. What's the in between 600 and 700 words? The average length of all these papers, is 87%. What if I want to find the I don't know, 80th percentile of this? It would be 693 words. And that makes sense. The 700, at 700, I'm almost at the 87th percentile. All right, let's say I want to ask questions about the sum length of 75 papers. And what's the standard deviation? 1625. Now I could ask all kinds of questions. What is the sum of the papers? What if this, can they be 48,000 words? All of them added together? Yes, they could be. And could they be 55,000 words? All right, so that gives me probabilities. It gives me the betweens. The 80th percentile here is 52,000 words. I can answer all kinds of questions once I know these, but it's putting several concepts together. What do I have to know? I have to know the uniform distribution. I have to know the mean and standard deviation of it in order to use the central limit theorem to calculate the distribution of the average of this many samples from this individual population. And if I use the sum of all of this, not the average, but the sum, I have to use the same mean and standard deviation of the individual items to come up with the mean and standard deviation of the sum and get this distribution. Now I can answer any questions. This is the whole point of this. They didn't ask any questions, but I kind of got to know what's going on, right? I think I could probably copy that over now. I think it takes a while to be accessible. So I can do these problems. I can do them, but you could do them by toggling back and forth from the book. And if you want to copy and paste things over and put them in your homework, one problem per homework page, you're in good shape. How about another one? Does this answer your question on the second problem? Bianca?
Yeah.
And then, if you don't remember, what can you do?
Look back.
I'm recording this. Gee whiz, I would be motivated to like remember it right now, because who would want to watch this again? I'm kidding. It's a boring joke, right? I'm falling asleep the first time, sitting through it live. I can't imagine the replay on video being any more interesting. Okay. How about problems from chapter 8? We still have some problems we've never done. Like this one. We've never really talked about the normal approximation to the binomial. That's another way of doing this. Here's a problem. For example, suppose a market research firm is hired to estimate the percent of adults in a large city who have cell phones. 500 randomly selected individuals in this city are surveyed to determine whether they have cell phones. Of the 500 people, 421 responded yes, they own a cell phone. Presumably, 500 minus 421 responded that they don't. Using a 95% confidence level, compute a confidence interval estimate for the true proportion of adult residents. in this city who have cell phones? How would you do that? Well, let's go look at example 810. It's an example. It will tell us how to do this problem. It's a population proportion. If X has a distribution, and maybe it's in the formula review. Let's see if it's there. Not quite. But we'll go here. If X is a binomial random variable, X has the distribution NP, where N is the number of trials, P is the probability of the success you're looking for. We can express that when N is large and P is not close to 0 or 1. It's kind of in between. The closer it is to 0.5, the more accurate this is. You can approximate X as normally distributed with what? NP, which is the mean of the binomial distribution, and square root of NPQ, which is the standard deviation of the binomial distribution. So to do a problem like this, what do we say? X, what's the distribution of X? If X is whether a person has a cell phone or not. It's binomial distributed binomial, and we know that's N comma P. Well, what's N? N equals, what's my sample size?
$500.
Perfect. What's my proportion?
$421.
Close. That's the numerator of my proportion.
Oh. Over 500? I don't know.
Exactly. That's the percentage of people that have cell phones. What is that percentage? 84%. It seems low to me, but let's assume that's right. Q, what's Q? We did the binomial distribution. It was a while ago. Do we forget it? Does this ring a bell? 1 minus P. So what's that? Equal 1 minus that. All right. So what's my X distributed as? It's binomial with 500, comma 842. What's wrong with this problem? It has nothing to do with statistics. It has to do with surveys. They surveyed 500 people. Holy smokes, they all responded. What's the probability of that happening?
Low.
If I sent emails, would I get 500 emails back? Do you own a cell phone? Very
Nope.
simple question. I probably I'd probably get like 50 back, maybe. If I was standing in a hallway and people were walking by, do you own a cell phone? I would imagine 8 out of 10 would say yes, no. Stupid question, which probably means yes. You might hear something like 2 words with the second one being off. So it's very ambitious that you surveyed 500 people and got 500 responses, but that's okay. Let's say we had 500 responses. Of the people that responded, 421, yes, they own a cell phone. Presumably 15.8% don't, 1 minus that. So what's the normal approximation? Of this? Well, I can go back to here. If we have x over n, which is your p prime, it's going to be equal to, so first of all, the normal approximation for the individuals is np square root of npq. This one is going to be np divided by p, so it's just going to be p times the standard deviation divided by n. This would be helpful, wouldn't it? Why don't I copy this? And I might copy that because it says, let's make it simple. But that time it worked. Knock me out. Okay. So this is population. Bold. Proportion using normal approximation. So what's the mean going to be? If I look at this, NP divided by N. Well, NP divided by N is just P, is it not? What is that equal to? That would be equal to this number. What's the standard deviation? Standard dev is going to be equal to what? P times Q divided by N, square root. All right, so SQRT P times Q divided by N. So it's going to be that. It's going to be 0.0016. We take it to 3 decimal places. Let's make it 4 decimal places. So P prime has what distribution? We're approximating with this normal distribution. Normal of a mean of 8.842 and a standard deviation of 0.0163. Can I answer any questions? Well, we want a confidence interval. It's 0.95. Significance, which will tell you, we're looking for the middle 95%. We're looking for the X low and X high. They give me the middle 95%. So what are the tails going to be? The significance, I can't spell significance. Is going to be equal to 1 minus the confidence. It's going to be 5%. That's both tails together. Each tail is going to be half of that. Significance divided by 2 is going to be equal to that divided by 2, 0.025. So if I go to my normal distribution calculator and I put my mean in as 0.842, and I put in, what do I put in? Standard deviation of 0.0163, 0.0163. And I want to find the lower tail, the lower limit, which is going to be what? I want a probability of 0.025 less than that. And it gives me 0.81. So let's put 0.81 in here, 0.81 there. And then I want to find the upper tail, which is going to be the right tail is going to be 0.025. So 1 minus 0.025 is what? I don't know. If I can't do the 1 minus significance over 2 is going to be what? Equal to 1 minus that thing, 97.5%. So let's go here and put 95%, 97.7. I want the 97.5 percentile, and that's 0.87. Of course, I can't type anything properly. 0.87. Why is my in between not what I want it to be? .975 and 0.025. I need more decimal places. Rounding error will kill you a little bit in this stuff. And if I put 0.025, oops, 81.01. Yeah, so now it gives me my middle 95. So close enough is close enough. My confidence interval would be what? 0.81 to 0.87, 95% confidence interval. That's how you do it. If I was assuming that 90% of the people on 90% of the people, if I wanted to say, make a claim that 90% of the people have cell phones, could I make that claim with 95% confidence? Where the lower limit of that confidence interval is 0.81 and the upper limit is 0.87? Can I? This is the part where one of you has to answer. If I want to solve this here, I can say lower confidence limits for 95%. I can say the lower limit, and I have an upper limit. How do I calculate those? If I don't want to use the calculator like I just did, I'm going to say this is going to be equal to norm inverse. And what are the arguments of norm inverse? Probability. I want the lower limit. I want the lower tail to be 0.025. And I want that mean and that standard deviation. So I get this number. And let's make it 4 decimal places. 8100.81. And for the upper limit, I want norm dot inverse. And what do I want? I want 0.975. And I want the same thing. I want this mean and this standard deviation. And I do boom. And I want 4 decimal places there. So if these are my confidence intervals, it goes from 81 to 87, 0.81 to 0.874. And I want to make the claim that 90% of the people have cell phones. Could I make that claim? Is 90% in the confidence interval. It goes from 0.81 to 0.874. Can I make that claim?
No.
No, I can't. I cannot. This is done on the average. There's nothing really mysterious about confidence intervals. And then by token, we do hypothesis testing, hopefully next week. We only have 1 day class, or 2 days of class next week. Well, Tuesday and Thursday. Friday we don't have off, and the following Monday we don't have off, straddling Easter. Another problem? Well, actually, why do another problem? Here's a try it one. And let's see if we got the same answer as the book. That would be helpful, wouldn't it? Let's see if we got the same answer as the book. Which one do we do? 810? 81874. What do we get? 81874. Good for us. Here's the one you get to try. Suppose 250 randomly selected people are surveyed to determine if they own a tablet. Of the 250 surveyed, 98 reported owning a tablet. Using a 95% confidence interval, compute a confidence interval estimate for the true proportion of people who own tablets. Go for it. I'll leave that here, and I should probably put the, where's the book problem? That's not it. There's this. So let's, here's what I'll do. Let me leave this open so you can see how we did this one. And let me paste this one here. So that you can see it all on one screen. Try it on your own Excel. I want to do what students sometimes do in my class. I'm going to check my cell phone while you're working on it. Okay, how are we doing?
Good.
Oh, maybe I would just copy this and put it right here. This is a similar structured problem. What has changed? What's the n in this problem?
$250.
Thank you. What's the p?
0.392.
So did you take, how did you calculate that? 98
8 divided by 250.
by 250. That sounds like a good idea. That's a great point estimate for the proportion. And automatically it calculates the q as 0.608. So my binomial distribution is 250 comma what? 0.392. And I can get rid of all this other stuff. Yay, good for me. Using a proportion, using a normal approximation, the mean is 0.392. The standard deviation is what?
0.0309.
Did I get the right numbers? I think I did. 0.0309. So my normal approximation is going to be what? Is this level of laziness that I'm using here okay? By using the same, why type everything over again? Point 0.0309.
Can you do how you got the standard deviation again?
Sure.
'Cause I got the wrong numbers.
It's equal to D15, which is P times Q divided by the sample size, which is 14, and I take the square root of the whole shoot match. Does any of this change? Well, we're 95% confidence. 1 minus that is significance, 0.05. Significance divided by 2 is 0.025. 1 minus significance over 2 is 0.975. So my lower limit, is it going to change? 0.025, comma, D20, D21. That didn't change. This didn't change. So I got my confidence interval, right? What if I want to change it to a 99% confidence interval? If I just put 99 there, is that going to change it? Yeah, yes, it's going to change it. It didn't change it because I'm still using the wrong numbers here. If I had put these two numbers in there, it would have changed it. So instead of 0.025, if I had put that, it would have changed it. Did it change it much? No, it didn't change it at all because I still didn't put the right number in there. And this one, I want to put that number in there. The reason I point and click a lot is so that if I want to copy it, let's say I want to do a 90% confidence interval, now I could do that. It just changes it automatically. That makes it pretty easy if I can do that. Do I want to do anything? Do I want to type the same thing twice if I don't have to? I just like to change some inputs. What are the inputs on this? What have we been using? Orange for inputs? What do we have here? These are not inputs. This is an input. I said orange, and what did I turn around and use yellow? That's an input. Pretty much that's all I have to enter here, and then the rest is calculable. Now, if you're doing it for the first time ever, you have to kind of remember all this stuff, but after I do it once, can I use, can I change this to, okay. I could even have it calculate the proportion if I wanted to. But let's say I had 1,000 people, and let's try this. Let's say I surveyed 1,000 people, and there's 2 candidates running for an office, and let's say I got candidate A and B, and let's say 501 people voted for that, or said that in a survey of 1,000 people, 501 said they were going to vote for, let's say 510, let's make it easy. 510 voted for my candidate, which makes my candidate has 51% of the poll, and the other candidate has 49% of the poll. And I go in here and I say at 95% confidence, my lower limit is 0.48 and my upper limit is 0.53. Is 0.5 50-50 in that confidence interval? Sure is, right? What does that mean? Can I conclude that my right now it looks like my candidate is ahead by 51 to 49. But when I do a confidence interval around that estimate, that point estimate of 51%, can I conclude that my candidate's leading? Somebody say no. And then tell me why. I can wait for 21 minutes. Let me ask someone. Anthony.
I'm not sure, honestly.
Okay, good answer. Is 50% in this range?
Yeah.
I cannot conclude. Because I can make the assumption that any of those with 95% confidence, any of those proportions are in there, right? 51 is in there, but so is 50. So I really can't, if my base assumption is that it's a toss-up, it's still a toss-up. My margin of error is 53 down to 48. It's a 5-point margin of error. That's exactly where they get that kind of stuff from. And that's a 95%, that's a 90% confidence interval. What if I made it 95%? Makes it even wider, the higher the percentage I go. So let's say I'm doing a 95% confidence interval, and I say my candidate is leading by 55%. Ooh, look where the lower limit is now. It's above 50%, right? The worst case I can assume for my candidate is 52%. So I can conclude that my candidate would win the election if it was held today based on this sample with a 95% confidence. This is exactly what they do in elections. The difference between this is a margin of error. We still have a 6% margin of error, but we're above, the lower limit of this is above, I bet even at 99%. Let's see what happens at 99%. We're still above 50-50. It's real close, but we can conclude that we're in the lead. If we had the election today, my candidate would win. This takes apart, discounts. We're ignoring any of the theatrics that would come afterwards about, conspiracy theories and fake votes and whatever else might be out there. We're assuming a fair, well-run election. Great. This is why you do study statistics. And it's nothing more magical than this. It's not like use statistics to get me these answers. I want this answer to come out, do some statistical magic and make it happen. We're just looking at what's the likelihood of, if this is in fact the binomial distribution, and it's not, it would be 250, it would be 1,000. I didn't change that, but it would be 1,000, 55. Here's the normal approximation to the binomial, which we would have a mean of 55 and a standard deviation of 0.0157. Using that, we can come up with a 95% confidence interval that would show that 50% is below the lower limit. Therefore, we could conclude that our candidate is in the lead. If the upper limit was below, we could conclude that our candidate would probably lose. There's nothing more magical about it than that. It's just a decision criteria that we're using, and we're using 95%. Let's we use 95%. Any questions on this? Can you now do these problems? I don't know. What's n? What's the sample size?
320 or 400.
400. X is the number of people that, it's a random variable. Does a person buckle up or not? And we surveyed 400 drivers. What's the point estimate of the proportion? It would be what?
320.
320 divided by 400. That would give me a proportion, right? I could copy paste this over and probably do this problem. If the survey were done by telephone, list 3 difficulties that companies might have in obtaining results. People don't answer their phone, of course. You'd have to call, to get 400 people, you probably have to call 2,000. That's just a guesstimate. All right, let's look at the next problem. Stanford University conducted a study of whether running is healthy for men and women over the age of 50. During the first 8 years of the study, 1.5% of 451 members. Now they gave you the proportion. They didn't give you the number that, of the 50 Plus Fitness Association died. We are interested in the proportion of people over 50 who ran and died in the same 8-year period. Define a random variable X and P in words. Which distribution should you use for this problem? Well, first of all, that's a binomial distribution. Second, constructing a 95% confidence interval. Well, you got to use the normal approximation to that binomial distribution. And guess what? You could copy paste and do a little surgery on this and probably get your answers. Pop your answers out. All right, should I post this? Which is better, in the announcement or in the chat here?
Announcement.
Okay, I
Yeah,
will do
announcement.
that like shortly. And I'm going to open it up to you guys to ask some questions. I can do any of these again. I can do a problem that I didn't talk about. If you're having a concept that you're not getting, it's a good time to bring it up. One thing I'm not good at is clairvoyance. So if you have a question, I can't feel your pain. I feel your pain, but I don't know specifically where the pain's coming from.
I'm still a little confused where you got the sig-2, like the 0.025 and the 0.975.
Oh, they give you a confidence level. Every problem says if they're going to want you to calculate a confidence interval, they're going to give you the level at which you want to calculate the confidence, right? They give that to you. By definition, 1 minus that is called significance.
Yeah.
If I look at, is that what you're talking about?
Yeah.
Okay.
So then this.
But that means,
Oh, okay.
so I'm looking for the middle 95%, an equal distance above the mean and an equal distance below the mean to get the middle 95%.
Okay.
So now I have two tails, a right tail and a left tail, which if I get them 95%, I know the two tails together are going to be 5%, right?
Yeah.
Which means each tail has to be half of that.
Gotcha.
But remember, the CDF, the cumulative distribution function of the normal distribution and of the t-distribution, only give you the probability of less than or equal to. So to get the right tail, I have to put 0.025 in the lower limit. And for the upper, I have to put 1 minus that, 97.5. So the right tail ends up being, 2.5%, but I can't calculate based on the right tail. I can only calculate based on the lower tail, the left tail, right? So
Yeah.
Here the left tail has to be 95.5%, 97.5%. That's where all that comes from.
Thank you.
Draw a picture of it. And reason it out. So the inverse norm only gives you it based on the left tail. So here it's saying, for this mean, this standard deviation, which are D20, D21, I want to find the 2.5 percentile point, which ends up being 51.92. For this upper limit, I want to find the 97.5 percentile point. Those are the 2 points where the in-betweens are going to be 95%. So I'm interested in finding those 2 points. That's what we're doing here. And then if our item of interest, if the claim we're trying to make is in that interval, we're trying to say we're better than this. Usually, you don't want to say, if right now, if we're doing like an election, the default would be the election is 50-50. I want 50-50 to be below the lower tail so that my candidate is shown in the lead. If it's in the middle of the confidence interval, I would have to call that election too close to call. How do we call it too close to call? If the 50th percentile point is in the confidence interval. It's that simple. There's no statistical magic to it. We've just made that a decision criteria. It's too close to call at that confidence level if the 50th percentile point in this election thing is in the middle of it. If the 50th percentile point is below the lower limit, I can conclude my candidate is winning. assuming the proportion I'm looking at is the proportion of my candidate's votes. If the 50th percentile point is above the upper limit, I can conclude that the opposition candidate is winning, would win an election if it was held today. At a 95% confidence. Is it a guarantee? It's not a guarantee. It's a statistical decision criteria that we're using. If we kept getting these numbers 100, you know, we did 100 such polls and we're there, we could conclude that our, you know, it's a kind of that law of large number stuff. And we're doing it on proportions of elections, which is like taking an average. So, but people can be very accurate. Obviously, the larger your percentage, like we made it 55%, and it showed at 95% that it was based on a sample of 1,000, we can conclude that. What if we had a sample of 300? We couldn't conclude that, right? See how the confidence interval flared up? Went down to 49 up to 60%. Just below. Okay, you can say, okay, maybe let's make it 90%. Now I'm fudging with statistics to get the answer that I want. If I change it to a 90% confidence interval, okay, now I'm winning again. So what are you trying to do? Do you want an accurate representation based on a decision criteria? Or do you want to stick to a steady decision criteria by which you're going to say, by this decision criteria, we're behind, we need to step up our game, we need to change tactics, we need to invest more in advertising, we need to do blah, blah, blah. So that's how that kind of works. You just saw how I changed some of the numbers and got the answer I wanted, right? When the federal government does drug testing, percentage of people, they could use a percentage of people that improved. You know, their cholesterol went down. They have specific criteria for sample size and confidence so that everybody's on the same level playing field about making claims. Here's how we're going to allow you to make the claim that this drug is better than the previous drug. It has to be at a 95% confidence. It has to be based on a sample of whatever, 300, 400, 500 people, 20 people, whatever the government has deemed. And based on that sample size and this confidence, if you show an improvement, you can claim it. If not, you can't. And that makes sense, right? So that you're not playing around with the numbers just to get the result you want. But remember, it's more of a decision criteria than it is any kind of statistical magic. We're assuming if this is true, if this normal approximation is true, or if we go back to this problem, where we used the standard error, and we have we use the EBM that the book requires coming up from descriptive statistics. If we have this sample of 12 and a 95% confidence interval, if we can make, if that's and we're assuming that this distribution is true. What's the distribution? That this is the mean and this is the standard deviation of it. With this, we get this lower limit and upper limit. And if the claim we're trying to make, if that confidence interval supports the claim we're trying to make, we can make the claim. If not, we can change it. We should abide by the rule we set up going forth. Not, oh, I don't like the decision, let's, well, one thing you could do is raise the sample size. That'll reduce the standard deviation. Because remember, when I raise the sample size, I'm taking the sample standard deviation and divide it to get the sampling distribution, I divide it by the square root of n. So as n goes up, that standard deviation gets smaller, so you get more precise as n goes up. A sample size of 9 may not be sufficient here. Increasing that is a good thing. You probably get more accurate results. But once you hit, like for a t-test like this, once you hit a sample size of 35 or 50, it's not going to change, shouldn't change your results that much. So now we're going to take it from confidence interval to hypothesis test next week. Are you in a position to do all your homework now? And let's turn everything in on Sunday or Monday. I probably won't grade it before then. I'll grade stuff that you turned in. I won't grade this homework until like Monday. And the previous homework that people asked for extensions on, I'll probably grade that. Maybe I'll look at that on Monday, and maybe over the weekend I'll grade the other two, the videos and the in-class assignment that you had to fix up and turn in. Can you work in pairs? Yes, of course. How can I tell you when it's a homework that you can't work in pairs or you can't work together? I don't want to see the same file though. The only time I can see the same file is if you're trying to use something like this in Excel and you have a Chromebook. Then you can turn the same file in as your partner. Because I don't think Excel really runs on Chromebooks or and you can't use data analysis on Excel 365. All right. Do we have any more questions? Was this a good session? Did it help
Yes.
you? Was it a murmur or a yes?
That was a yes.
Okay. I got one yes. That's good. Yay.
Yes.
All right. Let me save this file and put it on an announcement right now so you can look at it and see how I did stuff. And let me do this too. Let me make a copy of people that are here. So I can take attendance. Oh, there's more than that. Sorry, let's do that one. Let's see more. All right, I'll let you go. I'll stay on till the last person leaves. Hannah, if you could stay on, I would like to talk to you for a minute.
Have a good weekend.
Have a good
Thank
weekend.
you.